Previously, we worked on evaluating the relationship between a numerical and a categorical variable using statistical inference methods. Now we're going to take a modeling approach to this, and we're going to fit a regression model where the response variable is numerical and the explanatory variable is categorical. We're still working with the poverty variable from the US, but this time the explanatory variable we're considering is region. And this variable takes the value of 0 if the state is on the eastern side of the US and 1 if the state is on the western side of the US. So we can write our linear model as predicted rate of poverty equals 11.17, that's our intercept, plus 0.38, the slope, times region west. We're not going to talk about how to estimate these values right now. We're kind of giving those to you, but we're instead going to talk about how to interpret them. So, for states that are on the eastern side, what we want to do is to plug in 0 for the x variable. So that would give us 11.17 plus 0.38 times 0, just 11.17. So the predicted poverty rate for eastern states is 11.17%. For western states, we plug in the value of 1. So in this case, we're calling west a success, east a failure, if you will. And if we solve for that, the predicted poverty rate then comes out to be 11.55%. In regression models with explanatory categorical variables, we always code one of the levels of that categorical variable to be what we call the reference level. This is the level that we plug in 0 for. So then what do the slope and the intercept mean in this context? The intercept basically tells us that the model predicts an 11.17% average poverty percentage in eastern states. Remember, we've calculated this by plugging in the value of 0 for the explanatory variable because the variable is called region west and an eastern state is not on the west, therefore we're plugging in a 0 for that. The reason why we have to do this trick of plugging in a numerical variable is that we couldn't simply plug in a level, a categorical variable, and solve a mathematical equation, so we're making do by labeling some of the levels successes and some of the levels failures and denoting these with zeros and ones. The slope, on the other hand, is once again going to be about the actual relationship between the explanatory and the response variables. It tells us that the model predicts that the average poverty percentage in western states is 0.38% higher than in the eastern states. Let's take a look at a new categorical variable. We're going to call this variable region 4 because it has 4 levels: Northeast, Midwest, West, and South. So we've gone through our data set and identified each one of the states to be either in the Northeast, the Midwest, the West, or the South. We want to write the linear regression model based on the regression output below. Remember that to write the regression model, all we need are the slope and intercept estimates. So we're only going to be focusing on values that come from the estimate column in the regression output. Our response variable is percentage living in poverty, so we're going to set the predicted percentage living in poverty equal to the intercept plus 0.03 times the Midwest variable plus 1.79 times the West variable and 4.16 times the South variable. Once you have this linear model, depending on what state you're trying to do a prediction for, we can plug in a bunch of zeros and ones. For example, if you have a state from the Midwest, you would plug in a 1 for Midwest and 0 for all the other levels. Then, based on this, what is the reference level of this region 4 variable? Is it Northeast, Midwest, West, or South? Remember, the reference level is what we identify as the 0 level. And from the regression output, you can think about that level as the level that does not show up in the regression output. So what if I was to plug in a 0 for Midwest, 0 for West, and 0 for South? Then necessarily, such a state is going to have to be in the Northeast. So here, the reference level is the Northeast. Given what we know so far, we can calculate the predicted poverty rate for Western states. We're going to start with our linear model that we developed a couple slides before. And since we're looking for a western state, we would plug in a 0 for Midwest, a 1 for West, and a 0 for South. And all we have to do now is to solve the linear model. This is going to be 9.50 plus 0 plus 1.79 plus 0. The 1.79 is simply the multiplier for the west level times 1, and the other zeros are because we've plugged in zeros for the other levels. This comes out to be 11.29%. So we can say that the model predicts that the poverty rate for Western states is 11.29% on average.